which is equal to 1 minus 1 plus 1 minus 1 plus 1. Da, da, da. This is all true, right?
First off, I feel like I'm being conned, and this is exactly how you get conned. Because all you're doing is saying a bunch of random stuff and then asking me if I agree.
I mean, am I wrong?
I have no idea what you just. So if series
1
one
minus
equals
S1,
that,
yes, is equal to
and
this.
1 minus series 1 equals
This.
1 minus that same number.
yeah, is equal to 1 minus
So
1.
the problem is series 1 doesn't equal that.
Why not? I just named it that, and so therefore it does equal that. So 1 minus series 1 is equal to this whole thing right here.
Yeah,
Which is
but
then
you're
equal
lying to me when you
It's just
tell me
like
series
saying my
1
cat is
equals
a
that.
dog.
Which is then equal
Yeah.
to series 1. This right here is equal to series 1, right? 1
But
minus
it's-
1.
but it's not.
1 minus 1 plus 1 minus 1 plus 1, and so on and so on. So 1 minus series 1 is equal to series 1. And so therefore series 1 is equal to 1 half.
How?
Just-
That makes no sense. That makes absolutely no sense.
Oh,
just proved it.
no. Wait. Oh, yeah, I get you.
Okay. So that's the first
Because
series.
if series
I'm gonna
1
use.
is that, and 1 minus series 1 equals 1 minus that, that should equal series 1.
Okay.
Hold on. Are you saying that 1 minus
Yeah.
series 1 equals 1 minus series 1 equals series 1?
Yeah. Am I wrong?
Yes.
No, because it
Show
would be
me where
1
I'm-
But
minus
how?
series 1 again.
Show me where I'm wrong. If this goes all the way out to infinity and this goes all the way out to infinity,
1
it goes-
minus series 1 equals 1 minus series 1 equals 1 minus series 1, or equals series 1?
Yeah.
That can't be right, because it would
It's
have to
not.
equal 1 minus series 1 again.
Exactly. Because the ellipses say it's going on for infinity, right?
It would
So
equal
if you
1
think I'm
minus
wrong,
series
show
1
me
again.
where I'm wrong.
It's because this doesn't equal 1, this equals 1
1
minus
minus
series 1.
series 1 is
This
series 1.
is 1 minus series 1. This isn't series
Yes,
1.
but if you go over here and you separate out the negative sign, you get 1 minus 1 plus 1 minus 1 plus 1, all the way out to infinity, which is the same thing as series 1. Okay, second series.
Well, where'd you get the negative 112? Okay, never mind.
Second series is series 2. 1 minus 2
Jesus.
plus 3 minus 4 plus 5 minus 6, all the way to infinity. Now let me stop for a minute and
And remember that I forgot how to con you on this part.
Alright,
How
I
did I
have now remembered how to con you on this part. Okay. So this, if you add this to itself, S2 plus S2
Mhm.
equals 1 minus 2 plus 3, 4 plus 5 minus 6. Now I'm going to do something special with the second series. I'm going to move the entire thing over one. So I'm going to do plus 1 minus 2 plus 3 minus 4 plus 5 minus 6, all the way to infinity.
Do you remember why you moved it over?
you didn't move it over. You
Yes.
just added them.
This is therefore equal to 1 minus 1 plus 1 minus 1 plus 1 minus 1, all the way to infinity.
But
Which
why are
is
you
then
why are you
equal
moving
to-
it over?
Because that makes it series 1. We can get this equal to series 1. So 2 series 2 is equal to
Ah.
series 1.
But
And so therefore series 2 is equal to 1/4. Once again, can anybody tell me?
it's going to something about
Now,
adding them all together is a
I'm going to
112 or
do
something.
series 3, which is equal to 1 plus 2 plus 3, 4 plus 5 plus 6, all the way to infinity.
There's so many
So
anomalies.
series 2 is just 1/4.
Yeah, series 2, this 1 minus 2 plus 3 minus 4 plus 5 minus 6, all the way to infinity goes to 1/4. Then series 3, 1 plus 2, all this stuff. And now what I'm going to do is I'm going to take series 3
Series 3 is
and
gonna be 1.
subtract series 2 from it.
Dude, we should get Miss Beatty in here. See if she can even decipher
Series
this.
3 minus series 2.
She won't know.
This is 1
Dude,
plus
she'll
2
try and it'll be hilarious.
plus 4 plus
This Hux
5
is really
plus
easy because this Hux will actually tell you why you're wrong.
Oh yeah. What?
minus
She still likes being
1
supervisor, right? Doesn't she?
minus 2
Yeah, she'll help.
Alright.
She'll
plus
come in
3
some night.
minus 4 plus 5 minus 6. Now when you, all the way to infinity.
Your students, that's what you're doing.
Okay.
In
So
robotics.
when you subtract these two things,
Oh,
That
just-
is what we're
Oh,
doing.
These
just in
cancel
biology.
this goes to 4, this cancels out, this goes to
Getting them to
8,
draw
this
the whole
cancels
curve
out,
was
this
what
goes to
getting
12.
them to-
I hope that graph wasn't important. Because I
It's
just
a
kind
normal
of
curve.
ate
It's
it.
disruptive selection.
Okay,
Right.
so it goes like this all the way to infinity. Now, this series right here is 4 times the value of this series up here. 4 plus 8 plus 12 all the way to infinity is 4 times 1 plus 2 plus 3 plus 4 all the way to infinity.
I can't wait for this. There we go.
Okay? So then therefore, this minus this, S3 minus S2 is equal to 4 times S3. And so therefore, negative series 2 is equal to 3S3. Series 2, as proved down here, is 1/4. So negative 1/4 is equal to 3S3. And so therefore, S3, the sum of all the counting numbers, is equal to negative 112.
So is it gonna just continuously go up like that? The series will go up.
No, I'm saying that if you take all the counting numbers.
No, I'm
and
saying,
add
so
all of them,
series 1
But you
equaled what?
Series 1 is equal to 1/2.
And then series 2 was 1/4.
Series 2 is 1/4.
Series 3 is 1/12.
Yes.
So the next one's 120. No.
We don't have a series 4.
What's the factor that it's going up by?
There is no factor.
2, 4, 12.
This is multiplied by 2, this is multiplied by 3, but doesn't matter.
So then multiply that by 4.
Yeah.
12 times 4, so
But there's no series that fits
48.
that.
148.
what? There's no what?
There's no series that fits that.
Yeah, again, you're
We
just
don't
making
have a
this
series.
up.
Yeah.
Make a series 4 that equals.
Yeah.
But show me where I'm wrong if I'm making it up.
Dude, I could show you. I could show you where you're wrong because
How
I don't understand half of this. Because if you're doing it S, oh
Alright. Let me start back here.
my god.
Series 1 defined, I defined it as 1 minus 1 plus 1 minus 1 all the way to infinity.
Yeah.
Mhm.
1 minus series 1 is therefore defined as 1 minus parentheses 1 minus 1 plus 1 all the way to infinity. Which, if you take out the parentheses, you get 1 minus 1 plus 1 minus 1 plus 1 all the way to infinity.
So you distributed a negative.
Yes, I distributed the negative 1.
Wait, you can't do that.
Yes, okay.
So 1 minus 1 plus 2 is the same as. Can you distribute that one out? Are you allowed to do that?
Well, you distribute a negative 1.
You can distribute the negative.
There's but
And there's a reason you can do that, but it's too complicated to get into. So,
no, but wouldn't there be like a 1 before the parentheses?
where?
Yeah.
Where?
Wouldn't there, after the negative? No.
There doesn't need to be a negative one. There could just be a negative
This is
sign. It's
implied.
cancel. Yeah.
The 1 is implied because if you multiply anything by 1, it's the same thing.
Right, so then you could distribute the negative 1 and make and flip the positive and negative.
That's what he did.
That's what I did. 1 minus 1
Yeah,
plus
that's
1.
what he did.
And so therefore, this whole thing right here is equal to series 1 again. And so I just want 1 minus series 1 is equal to series 1, using algebraic manipulation.
It's not though. It's
Yeah.
the inverse. of
It's
series
the
one.
opposite, which is why I said before
You
the
make
sum of all
inverse
counting
series
numbers
1.
would be 0.
You can't tell me that series 1 equals the inverse of series 1.
I can.
You could say it, but it would be
Okay,
wrong.
You're right. You
He physically can.
I proved it. Show
But
me where I'm wrong.
Well, because like
If this goes all the
I'm
way
not
up
equal to
infinity-
the inverse of me.
Okay.
This cup isn't equal to the inverse
If I
of
take
this
this
cup.
series and go all the way
I
up to
can't just
infinity,
say this is equal to the inverse of the cup because I feel like it.
if this
Reality dictates that it's not.
if I take
So
this
you've made a mistake.
series and extend it all the way out into infinity, and take this series and extend it out into infinity, show me where the discrepancy is.
Because we don't understand how to put something out to infinity. There's an easier way to write that too, isn't
You're
there?
just naming random equations and calling them certain
Yeah.
Of course I am.
fractions.
This
Of
is a
course I
definition.
am.
This is a
Yeah, yeah, yeah.
definition.
So series
I'm
one
I'm mathematically
is
allowed
that,
to name
but the
this.
inverse of series 1 is not the same as series 1. Are you saying the inverse of series 1 is series 1?
1 minus S1, as defined here,
Is
the same
also
as this.
series 1.
every single term as it goes out into infinity is accounted for.
So
But wouldn't it be negative 1/2 if series 1 is 1/2?
What?
Or would, like, negative 2? would be
1
the
minus-
inverse
okay.
of- Right?
I just proved right here that 1 minus S1 is equal to S1. This is called, I don't know, this is somebody's
yeah, so
equation.
the inverse
I did not,
somebody's
I did
equation
not
found
prove
in
this
the
part. This part is mathematically verified.
right.
1 minus series 1 is series 1, series 1 is 1/2. This whole proof right here is not mine, it is mathematically verified. This also is not my proof. This is my proof.
So series 2 is 1, 2, 3, 4, and you keep switching the positives and negatives.
Yep.
And then that will be 1/4.
That's not the sum
And then
then.
series 3 is
No, it's not.
Show me
Sum is all the counting numbers, and you
just
just 1 plus 2
adding
plus 3
1,
plus 4
2,
plus
3,
5.
4.
There would be no negatives.
1 plus 2 plus 3.
And if you're doing negatives, you have to do 1 plus and 1 minus 1 and then 2 minus 2. You couldn't just go 1 minus 2 plus 3 minus 4.
Because you're
By the
still
way, if you
thinking
guys need to
in
leave,
arithmetic terms. I need
Yeah, I'm thinking in mathematics terms because you're
No,
doing
You're
math.
not thinking mathematics, you're thinking,
So your
you're
parents are
thinking in
waiting for
arithmetic
you.
terms. You're thinking 1 plus 2 equals 3. I'm not thinking about, I'm thinking about this in calculus terms. This is
Alright.
this is not arithmetic.
So we get to
So
this.
it's not then what's the point to it?
So we're
There's no
done.
point to it.
That it's not true.
That it was equal to like 120 something?
What?
120.
No, it was 112.
Negative 112.
I thought it was 112. No, 112 is 112.
So
Negative
1 plus
112.
2 plus 3 is equal to negative 112.
1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7, all the way out to infinity.
Isn't that one?
Equal to negative
There's a way to write that. Infinity n.
Yeah, I think so.
This is
Something like that.
This is another way to write it.
Yeah.
That is equal to.
Can't you do like infinity n?
And the best part about this proof, it's been verified. And in like many quantum physics equations, there's this series.
Yeah.
And if you plug in negative 1/12 to that series, you get results that are experimentally proven.
Yeah.
And like
Pretty.
sum of all the counting numbers.
Although this is the problem with quantum physics, is just because something's pretty doesn't make it actually real.
Okay,
I just watched a thing like how there's
this is,
either quantum physics actually isn't real, it's just the math is really pretty and it's wrong, or we have not yet figured out that quantum
have you
physics
been
is real.
recording this whole
I
time?
haven't recorded.
Okay, good.
What are you doing with this
If you-
recording?
I'm gonna post it.
Okay, there's
Because
one
it's
thing
hilarious. Are we trying to prove
that
this?
I have to
Makes
say.
no sense.
It's not just him.
This is not
it's
the
thing.
actual way to prove
It's
this.
it's not a real
Exactly
thing.
to prove it.
This is not the actual way to prove it. The actual way to prove this is by using something called the Riemann zeta hypothesis, which is another function. It's very
It's like
complicated.
a 40-page paper.
Yeah. And it's what's called a millennial problem, which means nobody solved it yet and it's existed for 200 something years. So, this
Is zeta a dude or is zeta the number?
zeta is the name of the function. Riemann is the name of the guy that created it.
Okay.
This
I don't
is
think I didn't think there was a doctor named Zeta somewhere. That would be
Professor
one.
Zeta.
Yeah, Professor Zeta.
This is now that everybody that I care about's left them. This is technically
Thanks.
incorrect because and only for one reason, because you cannot algebraically manipulate infinite series.
Yeah,
You can't do that.
that's right.
But that being said,
It still works.
it still works, which is the funniest part about this whole thing.
Awesome.
And these all of these series 1, series 2, and series 3, or I don't know if series 3 has, but I know that series 1 and series 2 have
Can you
both
set
been
up an
mathematically
infinite
proven.
series as an actual? There's a number. Isn't n an infinite series?
I don't get your question.
Isn't there? Sorry. Can you set up an infinite series as a variable to represent an infinite series?
I mean, you could do.
Oh,
this. You
factorial. Factorial is an
can do
infinite
this.
series.
There's nothing stopping.
Isn't factorial an infinite series?
No.
Oh, it goes down to 0.
But what you're thinking about is what is called a Taylor series or a Maclaurin polynomial, and that's essentially taking an infinite series, or not an infinite series. That's taking a function like e to the x, and taking the derivative of that over and over and over and over and over again, and then making a polynomial so that the polynomial has the same derivative, second derivative, third derivative, fourth derivative, all the way up to infinity. That's an infinite series. That's a Taylor series. That's another branch of mathematics altogether.
But you can't.
The issue with this series, because I really have to go soon, is that the issue with these proofs, although technically they are all true, nothing I said was a lie.
Right.
But the issue with what I said was that you can't manipulate infinite series in the way that I did. Especially, you can manipulate convergent infinite series, but you cannot manipulate divergent infinite series. And technically speaking, these are all divergent infinite series, except for, I don't know if series 2 is divergent.
What's divergent about it, or converging? What's
Uh,
converging or diverging?
It's only because series 2 is an alternating series, so I have to do more calculations for that. But yeah, while you are technically correct, I am also technically correct. And so therefore, we can all be happy.
That's
Yeah.
fair. That's valid.
Well,
What are you gonna do with that recording?
I'm probably gonna love it because it has Ernest in it. They can't help
I didn't
you.
bring my backpack